Okay. All right. Okay, so we're going to make a table of values for this next example showing 2 to the 4th through 2 to the 1st. So let's start with 2 to the 4th power. What does that equal to? 2 times 2 times 2 times 2. 2 times 2 is 4. Yep, 4 times 4 equals 16. Good. Okay. 2 to the 3rd power. Does anybody know what that is? That would be, yeah, half of 16. 2 to the 2nd power is 4. Okay. 2 to the 1st power is 2. 2 to the 0 power. Try and extend to 2 to the 0 power is 1. How many people knew that was 1? Do you see the pattern? What is the pattern that we have going on here? Oh, it's dividing by 2. As we lose an exponent, we're dividing by 2. Because essentially, 2 to the 4th power divided by 2 is going to be 2 to the 3rd power. There's a lot of math involved in this pattern here. How do you think we got, why do you think we got 2 to the 3rd power here? If I divide by 2. Yeah, we're dividing out, right? So if you see this, 2 to the 4th power is 1, 2, 3, 4. If I divide by a 2, that becomes they cancel out, right? So essentially I could say, well, this is the same thing as 2 to the 4 minus 1. And each time we're taking half, half, half. Yeah? Do you see that pattern? Everybody's with me so far on that? So what would the next one be? If I continue the pattern of the exponents, let's call this 2 to the n power. Okay, if I continue, after 0 comes -1. Half of 1 is 1/2. Right? 1/2. Or did you get 0.5? You get 0.5 is the same thing, right? 0.5 is the same thing. 0.5. 2 to the next one would be in the pattern, 2 to the -2. And what do you think that would give us? 1/4. Half of 1/2, right? And if you have 2 to the -3rd power, what do you think that one is going to be? 1/8. Half of 1/4 is 1/8. Now, there's actually a simpler way for the rule. What could I say a rule is? What does the negative exponent, how is it different than the one that has the positive exponent? So what's the relationship between 2 and 1/2? What's the relationship between 4 and 1/4? What's the relationship between 8 and 1/8? Do you see what the negative exponent is doing to the number? Reflippercle. Oh, it's the reflippercle, isn't it? Right? When 8 becomes 1/8, 8 over 1 becomes 1/8, we call that the reciprocal. Reciprocal. Okay. For fun, one of my students told me they remember it by saying the reflippercle. So that's just a funnier way of trying to remember the reciprocal. So the negative exponent is telling us to just flip the number. It doesn't have anything to do with the sign of the number, just because the exponent is negative. So what's happening is the pattern is we're dividing by 2 as we lose an exponent. So that's where you're seeing this 1 divided by 2, 1/2 divided by 2 would be 1/4. Let's draw that out. So if I have 1/2, half of half is 1/4. Half of 1/4 is 1/8. Half of 1/8 would be 1/16, and you're seeing these numbers in reverse. So 2 to the -4 power is 1/16. Does everybody see that? And you can double check these. We're gonna want to know them, and we're gonna learn all the rules. But for now, as we're learning, we could double check them on the calculator. So I'm just gonna squeeze the calculator in here. Let's prove 2 to the 0 power. And for an exponent, I do use this little caret, little v, okay? And that's the same thing on your computer too. If you are typing in an exponent, you'll do a shift 6, because right above the 6 on the keyboard is this same v type symbol, the little caret. Well, it really is an exponent. I don't know what the symbol itself is called, but we use it for an exponent. That is a good question. Maybe there is a name for it. You'll look it up and let me know, okay? Let's try the negatives. 2 to the, and for the negative, I have to use the negative symbol here, -1. And why did I get 0.5? I thought it was 1/2. Oh, it's a decimal form. By the way, your calculator, most of them will change between fractions and decimals. So if I do second, and then here's that, everything in my calculator in yellow is controlled by the second key. If I do second, F to D, that's going to change the answer from decimal to fraction or back and forth. So now I get 1/2. That's a really cool feature too. Okay, so that way you're seeing the pattern more. But if I do 2 to the -4th power, I'm going to get the decimal equivalent of 1/16. How do I know that that's the decimal equivalent to 1/16? I have it memorized, but also I could go second F to D, fraction to decimal, and it will tell me. It will change the decimal back into a fraction. Okay, any questions on those patterns there? This pattern right here of taking, fractions, half, 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 that actually, there's a little story that goes along with that, which is the Cookie Monster goes into the kitchen and he eats half the cookie one day, and the next day eats half of that, so he eats 1/4, and the next day eats half of that, he eats 1/8, right? And the next day eats half of that, and then the final question is, how long will it take before the cookie is gone? It will never disappear because we'll always be taking half. And when you get to your chemistry classes, that might be a half-life problem. Have you ever heard of half-life? No? It's like exponential decay. Well, anyway, you'll get into all of that in your advanced classes. And then remember me. Think back, okay? So let's look at the rules. We have a lot of rules, and this is where I'm saying, I was talking recently with a student who said, learning math is like learning a language. It's a symbolic language, right? But we do have to follow certain rules, and so putting these rules on flashcards could be helpful. Let's give an example of each of them. So number 1, the product rule. If I have 2 to the 3rd power times another 2 to the 1st, what's that give me? To the 4th, because we add the exponents. That's when we're multiplying. So product, the word product, what does the word product mean? Yep, it means multiply. Answer to a multiplication problem. Power of a power, you're going to see parentheses, okay? So let's do number 2 to save space. Let's say I have 3 squared to the 9th power. What's that going to be? Three to the 18th. Oops, not 2. 3. 3 to the 18th. And if you do 3 to the 18th, this is where I was saying the difference between exponential notation and versus standard form. 3 to the 18th, because there's no variable there, it's just a number. But if I go 3 to the 18th, I'm getting a really, really big number. So I'm finding it simpler just to go ahead and write it in exponential form than to write that ginormous number, which is like, 387 million, something like that. Maybe. What's that? 3, 8. Well, I mean, if I wanted to prove the rule, I could write it out in standard form. But because I'm just using the rule, the power to a power rule says I multiply the exponents. So that's where we get the 18th power. And what I'm saying is I would just leave it as 3 to the 18th as opposed to writing it out as 387 million or whatever the number was. Okay, number 3, product of a power. So these ones are the ones that we just reviewed that we know already. Negative 3x to the third to the second power. What would that be? So this square means I'm going to multiply the number by itself, right? So that's going to be negative 3 squared, which is negative 3 times negative 3. That's where I'm getting the positive 9 from. And then x to the 6th power. It is really hard to switch your head around from what do I do with the number, what do I do with the variable? Yes. Where are we at? This problem exactly? Because 9 is a much smaller number. If you want, we can write this out as 387420489. Oh, sure. This would be the same thing as 9 to the 9th power. Then yes, that would be the same thing. Is that what you're asking? Three to the 18th power is the same thing as 9 to the 9th power. Yes. Yes. Actually, look at that. We could go 9 to the 9th power. It's the same exact thing because that's 3 squared. Okay. So I'm just showing the work here for this. I was putting the answer there, but we were talking about it. Okay, let's look at number 4. Number 4 is saying anything, the zero exponent rule, a to the 0 power is 1. So if I had 2 to the 0 power, that would be 1. What if I had negative 2 to the 0 power? What would that be? Be careful because that negative is not in parentheses. Negative 1. Okay, and we're going to get to that in just a second. That is a really good question. Why is it 1? I will get to that in just a moment, okay, when we get to these rules. Because the quotient rule is going to help us with that. Well, actually, let's get to the quotient rule first. What if I had negative 2 times negative 3 to the 0 power? Any thoughts about that one? It's a separate problem. Just giving another example. So in order of operations, we always do our exponent first. The 0 power makes that 1. 1 times negative 2 is negative 2. So let me do it. Let me slow it down. Negative 1. So this becomes 1. Negative 2 times 1 is negative 2. Okay, let's actually prove why this rule works right now, okay? So what if I did it this way? What if I said, this is for number 5, we're going to talk about the quotient rule. Does anybody know what quotient means? Product means multiply. Quotient means, yes, it's the answer to a division problem. Quotient, divide, okay? So let's say I'm dividing 2 to the 3rd power divided by 2 to the 3rd power. That would be 2 times 2 times 2 divided by 2 times 2 times 2. What is anything divided by itself? 1. Anything divided by itself is 1. Okay, let's do a different example. Let's say I have 2 to the 3rd power divided by 2 squared. 2 to the 3rd power is 1, 2, 3. 2 squared is 2 times itself, 2 times 2. So what is going to cancel there? 2 of the 2's, right? Because 2 divided by 2 is 1. 2 divided by 2 is 1. And what's left? 2. What's the exponent on this 2? 1. What can I do with 3 and 2 to give me 1? When we multiplied, we added them. When we divide, we're subtracting. So this is really the same thing as 2 to the 3 minus 2. Yeah? Which is the same thing as 2 to the first power. Okay? So that's the rule for when we're dividing and the bases are the same, we're going to subtract the exponent. That's the quotient rule. So that actually proves the 0 power, because if I say 3 minus 3, what is 3 minus 3? 0. So 2 to the 0 power is the same thing as 1, because I would subtract the exponents. 3 minus 3 is 0, right? Do you see that rule? How that works when we use the quotient rule? So because the exponents are the same and we're dividing, anything divided by itself is always 1. If we use the quotient rule and we subtract, we can see that 0 exponent, why that becomes 1. That's how I prove that 0 exponent is 1. Right. As 1. It's basically because what is following, it's because it's really because of this pattern, right? If we're following the pattern down, we wind up here with the 0 power being 1. And that's also goes back to the quotient rule. It's like, if you balance out the numerator and denominator, what if you had actually, this is a good question here. What if I'm going to skip 6 for a second. I'll come back to it. Let's do 7. What if I switch it? And I'm going to switch to x instead of 2. I mean, it's really the x is replacing the 2. It's just standing for it. So let's say I have x to the 3rd power divided by x to the 5th power. So here's a situation where I have more in the denominator than I have in the numerator, right? So if I were to write this out, x to the 3rd power means x times itself how many times? X to the 5th power means x times itself how many times? 1, 2, 3, 4, 5. What is x divided by x? Any number divided by itself is 1. Yes, I said I was going to come back to it in just a second. So all of those cancel out with each other, right? Leaving what? What's in the numerator? If these are, what is x divided by x? X divided by x is 1. So in the numerator, I just have 1, don't I? What do I have in the denominator? 2. Okay. Oh, wait, x squared, not 2. X squared, right? I have 2 x's. That's what you meant by 2. Okay. What would happen if I subtract these things? 3 minus 5 is, it would be x to the negative 2. That's where we're seeing that reciprocal again. The negative exponent, this negative exponent is the same thing as 1 over x squared. Do you see that? So we never want to have a negative exponent. We always want to make it positive. So to make it positive, we'll take the reciprocal. But we can always write it out. And this is what we call expanded form right here, expanded. And apparently, I think other people write smaller than I do. So I'm taking up way too much space. We're going to go back to this negative exponent. So right now, let's do number 6. Since I skipped number 6, we'll go back to number 6. So here is number 6, the quotient rule. So basically here, if I have quotient rule with a power, because quotient to a power rule. So basically this is saying, let's say I have 1/2 and I square it. What is 1/2 squared? This is number 6, by the way. It would be 1/2 times 1/2, right? Which is 1/4. So that's all that rule is saying is, if you have a fraction in parentheses and you're taking it to an exponent, you're going to apply that exponent to the numerator and the denominator. You see what I'm saying? That's all that number 6 is saying. That's where you're getting the 1/4 from. Okay. Any questions on that one? I know I skipped over it. Okay, let's come back to these two rules now, 7 and 8. So I'm going to put them both on the screen, 7 and 8. All they're saying is, this is actually the way I usually describe it, okay? So you have a house. You're a condo owner. Actually, you're a landlord. How do I know it's a house? Because it has a chimney, okay? So if you are a landlord, you want to keep your tenants happy, don't you? You don't want them moving out, right? Because then you will forego the rental income that you would be earning. So let's say you have x to the -2 living upstairs. If you want to keep that, because this is the fraction bar right here, if you want to keep that tenant happy, what you're going to do is you're going to take the reciprocal. That's going to become x squared when it jumps over, because that's what the reciprocal was saying. Let me go back just really quickly to what we saw over here, right? You saw the pattern with the powers of 2. And what did the negative exponent do to x, or 2 to the first power? What did the negative exponent do to it? It flipped it. It took the reciprocal. So if I have, let's just try actually a few where we expand. So if I have x to the 5th over x to the 5th, that's going to be what? It's going to be 1. Anything divided by itself is 1, and it's actually the same thing as x to the 0 power, okay? If I have more on top, x to the 5th divided by x to the 3rd, it means any number to the 5th power. 1, 2, 3, 4, 5. 1, 2, 3, 4. Oops, 1, 2, 3. Right? What's left? X squared. So that was the same thing as x to the 5 minus 3. We subtracted the exponents. That's how we got the squared, right? If I go to x to the 3rd divided by x to the 5th, if I just use my rule of subtracting, I have to be careful in which order I subtract the numbers, right? So if I go 3 minus 5, I'm going to get -2. I never, ever, ever want to have negative exponents as my final answer. I can have negative exponents show up, but then I want to make everybody happy. I just want to make everyone happy. Okay? So how can I make the 2 go from negative to positive? Yes? 1 over x squared. Okay? If I have a negative in the denominator, okay, I'm going to do my little house example again. Okay? I don't have anyone, I actually just have 1 living alone upstairs. I have a fraction. I have x to the -2 in the denominator. They're living downstairs. It's too cold for them downstairs. They're not getting enough light. They're going to move out. What do I do to retain my tenant? Anytime I have a negative exponent, it has nothing to do with the sign of the number. I flip it. So the negative, once it goes upstairs, this is the same thing, 1 over x to the -2 is going to become x squared. If you want, you could put over 1. So once you move him upstairs, he's positive. Okay, anytime you have a negative exponent, take it from either the numerator to denominator to make it positive, or from the denominator to the numerator to make it positive. Does that make sense? So this would be our answer here. If I have x to the -2, that's the same thing as 1 over x squared, because you always need to remember that you have an upstairs and a downstairs, numerator, denominator. Let's stop there and see what we can do from the packet.